Welcome to the fundamentals section of the course. In this section, we're finally going to get to writing valid VBA code in the Visual Basic Editor. But before we get there are some other fundamentals that I want to cover. I know that this material may be a bit more dry, a bit more technical and boring, but it's important to lay a good foundation here because if we're willing to invest our time and energy up front, it's going to pay off a lot when we start applying these ideas to more technical concepts within VBA. I want to begin here with a discussion of object-oriented programming. What is that? Well, as I mentioned before, VBA is an object-oriented programming language. Object-oriented programming is a development paradigm, which just means a way of thinking that views a software application as a collection of objects that talk with and interact with each other. The first question you probably have is, okay, what is an object? Well, an object is some kind of entity. It's a data structure. It's some kind of thing. If you take a look at the objects around you, the real world objects that you see, you may see a computer, you may see a lamp, a bed, a drawer. We as humans are able to differentiate between these things. These objects are different entities that we recognize, and we can do different things with these objects, and these objects also have different attributes about them. Code and the computer have a similar design concept, right? Excel needs the ability to differentiate between different data structures. What are some of the objects that we might run into in Excel? Well, you can think about a workbook versus a worksheet versus a cell range. Excel needs to be able to differentiate between these things, much like we as humans differentiate between these things. And that's accomplished in programming terms by identifying each one of those things as a separate object, right? It's just a different thing within the context of the application. Each object has its own set of properties and methods, okay? A property is like an attribute, a detail, or a characteristic about an object. A property defines what the object looks like and how it acts. It's some kind of characteristic about it. You can think of it almost like a passive detail, right? It's not an active activity that we're doing with the object. It's something that describes the object's state. In comparison, a method is an action or a command that we can do with an object or on an object. I know that right now these ideas are very high level, so what I want to do over the next couple of slides is to apply these principles to a couple real life objects to kind of give you a better understanding of what I mean when I say properties and methods. A really good way to think about it is in the context of language. An object is like a noun. A noun is a person, place, or thing, right? You can think about, again, the objects around us, a water bottle, a refrigerator. These are objects. They're things that we can interact with. Those objects have properties, which are details about the object, right? Properties in the context of language are like adjectives. That car, which is an object, is red. Red is describing the color of the car. So color can be thought of as a property, and red can be thought of as a value. A method is like a verb. It is an action. What can we do with a car? We can drive a car, right? We can fix a car. We can sell a car. So an object is like a noun, a property is like an adjective. It's some kind of descriptive way that we can talk about the object and what it looks like. And a method is something that we can do with the object. It's a verb. Let's reinforce these concepts with a couple other real-life objects. So here I have three objects. I have a book, I have an apple, and I have a basketball. And I want you to think about some of the properties or characteristics that these three objects might have, as well as some of the methods, which are the things that we can do with these objects. And here's a few that I came up with. Feel free to come up with some more of your own. There's no right or wrong answer here. So what are some of the properties that I can see on a book? Well, a book will have a name, a book will have an author, it will have a certain number of pages, and it will have a price. Notice that none of these things are things that I do with a book, right? These are not verbs that I would ever use when writing something about a book. These are rather details that describe what the book is like, what its shape is like, what its structure is like, what its state is like. In comparison, methods related to a book, things that I can do with the book, include reading. I can read a book, I can sell a book, and I can trade a book. Let's dive into another example with an apple. An apple may have a property of a color. That value of that property may be red, just like an adjective. An apple may have a red color. Variety, the type of apple that we're dealing with, is another property. An apple may be a Granny Smith apple. It may be another kind of apple. An apple may have a price property. That price can be 99 cents. It can be 49 cents. Different apples can have different price values. Again, properties are just characteristics that describe what the object is. A price is not something that we can necessarily do with an apple. It just describes the apple. What can we do with an apple or with any object? What we can do is what we call the methods. So methods related to a real-life apple are eating it, we can slice it, and we can wash it. Finally, with a basketball, some of the properties I can think of on a basketball, it has a color, orange, it has a weight, 3 pounds, and it has a company that makes it. Some of the things we can do with a basketball, some methods, we can throw a basketball and we can sell a basketball. An important thing to notice here is that different objects can share the same properties. For example, the book and the apple both have a price property. In real life, nobody would confuse a book for an apple. They're two different objects, they're two different entities, they're two different things, but they both may have similarities. They may both have a price. Similarly, objects may have the same methods. For example, the book and the basketball both have a sell method. A book is a totally different object from the basketball, but they can both be sold. We can both do the same thing to them. Objects may have unique properties. They may have shared properties or identical properties. Objects may have unique methods that are exclusive to them, and they may also have shared methods. To conclude this lesson, I want to dive into a little bit of the technical syntax that we'll be using in VBA when we're dealing with objects. So let me just bring up this slide right here. This is a lot to take in, so by no means do you have to memorize all this stuff right now. I just want to introduce you to the syntax so it's not going to feel as awkward when we throw all this stuff at you a little bit later, okay? So there's 3 things that we can do here. We can get a property, we can set a property, and we can call a method. The syntax for getting a property value, which means finding out a characteristic about an object, looks like this. We have an object, we have a dot, and then to the right of the dot, without any spaces, we have the name of the property. You can see that in the middle of the table right here. So let's take a look at the 2 examples in the right-hand column. Let's say we have a book and a basketball object in the context of a program like VBA. A book, as I mentioned, may have an author property. It's a characteristic about the book. And we can reference that property. We can get the value by writing the name of the object, book, then a dot, then the property name, which is author. And that will return to us an author, like, let's say, George Orwell. Similarly, if we have a basketball object, we can reference a color property on it with that dot syntax. Object, then a dot, then the property on the object that we want to access, and that will give us a value like a basketball color, let's say, is orange, okay? Now, predictably, if an object doesn't have a property, then we're going to run into an error, but we can dive into that a little bit later. Some object properties are what we call read-only, and that means that they can only be read. We can only get them. We can't change them. For example, in real life, a book will always keep the same author, right? However, there are some object properties that can be overwritten. They're not read-only, they can also be written, right? We can read them, we can write them. That means that new values can be set. For example, a book may have a price right now, but that book's price can also change when the shopkeeper decides to give it a different price. A basketball may have a color of orange, but we can always pick up the basketball and paint it and give it a new color of black, right? So some properties can be overwritten. The syntax to set a property value, to give an object property a new value, is very similar. On the left-hand side, we're going to have the object, a dot, and the property. And then unlike the syntax for getting a property, we're going to write an equal sign. And then on the right-hand side, the new value that we want to assign. So let's take a look at the 2 examples here. If we do just book.price, we're going to get the current price property of a book, which is going to be some kind of number. If we want to overwrite that, if we want to set the price property to something different, we do book.price equals, and on the right-hand side, the new value, which let's say arbitrarily is $14.99. Similarly, if we want to change the value of the color property on a basketball object, we would do the object, basketball, dot, the property, which is color, an equal sign, and the new value on the right, which in this case is black. I want you to notice here that black is written in double quotes, and this is very important. When we have something written in double quotes, in programming terms, we call that a string. A string represents a collection of text or characters. So anytime you're going to be writing words, things with spaces, names, you're going to be using strings. And whenever you write a string, you need to do double quotes. You do not need to do double quotes if you're doing things like numbers, as we have here with $14.99, with either floating point numbers with decimals or whole number integers. But whenever you're using some kind of text as a property, like a name, you're going to have to use double quotes. We're going to repeat this many times, so don't worry about memorizing it now. Finally, we have a syntax for calling or invoking a method on an object. And when I say call a method, I just mean to run it, to execute it, to tell the object, hey, you have this functionality, you have this ability, I want you to do it, okay? The syntax is exactly the same as it is to get a property value. It's going to be the object followed by a dot, followed by the method on the object that we want to execute or call. You might be looking at these syntax options and saying, but hey, the object property syntax for getting a property value is very similar to the object.method syntax for calling a method. And you're absolutely correct. The syntax is essentially identical. We have to ourselves know whether we're calling a method or getting the value of a property, because VBA is not always going to tell us, okay? But the syntax is going to be very similar. Let's take a look at these two examples. Again, these are real-life objects. These are not things that exist in VBA, but just like we have apple and basketball here, we're going to be applying these concepts later to a workbook or a worksheet. So in order to invoke the eat method on an apple, we write the object, apple, a dot, followed by the word eat. We have basketball, the object, a dot, and then the word throw, which is the method, what we're asking the object to do, okay? This is a very big picture overview of objects, methods, and properties. And in the next lesson, the assignment, what I want you to do is to take some of these concepts and apply them to the real-life objects around you. Hopefully that will give you a better sense of the ideas that are being discussed here. And once you start thinking about real-world objects in this sense, it's going to be a lot easier to apply these concepts to VBA objects in our environment, okay? So I look forward to seeing you in the next lesson, and get ready to tackle your very first assignment. In this lesson, I want to talk a little bit about collection objects, again in a real-life context. I want you to think about an object like a bicycle. A bicycle can have properties like maker, gears, and year, and a bicycle can also have methods like ride and paint, things that we can do with it. Now, VBA, in addition to the concept of a single object like a bicycle, has the concept of a collection object. A collection object gathers together one or more related identical objects, okay? And syntactically, in VBA, a collection object is always going to be the pluralized version of a single object. Let me provide you with a more concrete example. Imagine we have a bicycle shop in our neighborhood, and it's going to have multiple bicycles, right? So imagine bicycles as a collection object. It is an object that represents a collection. Think of it like a box in real life. A box can store multiple things together. In VBA, we have certain objects that exist solely as containers for other related objects. So a bicycles object with an S at the end, the plural form, is a collection that collects multiple bicycle objects, singular. So in this case, I have a bicycles collection object that is storing 3 different bicycle objects. These are 3 completely different objects. Each one of these is going to have properties like makers, gear, year, and methods like ride and paint, but the property values on each may be completely different, right? These are 3 different bicycles that we're storing. Many times what we want to do is to reference a specific singular object within a collection. For example, in VBA, we have a worksheets object, which represents the entire collection of every worksheet that exists in the current workbook. And many times we want to say, hey, get just the second worksheet in that collection and do something with it. The important thing to remember here is that collection objects and individual objects are totally different things. Bicycles is going to be a collection object that's going to have its own set of properties and methods. Just because it's a collection of something else doesn't mean that it's a different idea. It's still an object. It still has the concept of properties and methods. It's just an object that's going to hold other objects which will also have properties and methods. In VBA, the syntax that we use to reference a specific object in a collection is this. We write the entire name of the collection, in this case bicycles. We give a series of parentheses, opening and closing parentheses, and inside we write the numeric index of the item. What I mean by index is the position in which it's in, okay? So in this case, we're writing number 1 because we want the first item in our collection, and you can see it's pulling out this red bike that's at the very beginning of our bicycles collection. The count in this case, when it comes to collection objects, always starts at 1. This is not always the case in VBA or programming in general. Sometimes the count starts at 0. But when it comes to collection objects, the first item, the first object within that collection is always going to be referenced by the numeric value 1, and the second bicycle by the numeric value 2, and so on. So when we use this syntax, bicycles, parentheses 1, we are pulling out a single object from the collection. In the example below, I have bicycles 1, maker, right? Maker represents a property, but here's the tricky part. Here's where it gets confusing. The maker property here that I'm referencing is not a property on the bicycles collection object. Rather, it is a property on a singular bicycle object. How do I get to a single bicycle? That's because when I use that parentheses syntax, I'm pulling out just one bicycle from this collection, and then I'm referencing an existing property on it. Let's give you another example, this time with methods. Let's say I want to call a method on another object in this collection. For example, in VBA, let's say I want to do something on the second worksheet in my worksheets collection. In this case, bicycles is my collection, so I use the parentheses with a 2 to pull out the second bicycle object from my collection. Once I have that, I can call a method on it like ride. You'll notice we're combining the syntax from the lessons before. We're still using the object dot syntax followed by the method here. But in order to get that object, we're no longer writing it directly like bicycle. Rather, we're extracting it from a predefined collection of related objects, right? Finally, one more example here that I can provide. Let's say we want to set a new property value on one of our bicycle objects. Once again, I have to take it from an existing collection, from a box that's containing all of these related objects. So I reference bicycles, my collection. In order to pull out a specific bicycle, I give parentheses and the number, the order of the bicycle that I want to pull out. So in this case, I'm doing bicycles 3, which is that blue bike at the end. Once I'm pulling it out, I'm getting back a bicycle object, singular. That's going to have properties and methods. In this case, a bicycle has a gears property, which can be read and it can also be overwritten. It's not a read-only property. So here I'm setting that gears property equal to 5. That's all there is to cover in this lesson. I just wanted to introduce the concept of collection objects, essentially an object that acts like a box. It collects related objects together. We pull out individual entities, individual items from this collection by using parentheses. It's going to be the exact same syntax when we translate this to workbooks, worksheets, and so on. In this lesson, I wanted to introduce the idea of objects serving as properties to other objects. This is a pretty complex idea, but once we understand this, it's going to tie together a lot of the concepts that we've explored in previous lessons. So I want you to imagine two objects here. On the left-hand side here, I have a book object and an author object with some pretty familiar properties and methods. And so far, whenever we've accessed our properties on our objects, we've used that familiar dot syntax. And our values have been simple data types, things like strings and numbers. For example, if we have a title property on our fictional book object, it may be equal to a string like Animal Farm. Notice here that our string, our text, is once again represented in double quotes. This is a requirement whenever we're using text, which is called a string in technical terms. Similarly, if we did something like book.pages, that may be equal to 100, and that is going to be a simple data value, an integer, just a whole number. And if we wanted to access a method, it would just be something like book.read. So here's where it gets really interesting. Stay with me here. An object's property can be a reference to another object, okay? Take a look at the two objects on the left here. The book has a property called author, the very last one. Imagine that that author property is not a basic thing like a number, but imagine that it represents the entire author object that you see below. So when I do book.author, I'm not going to get a simple value. I'm going to get the entire object that we see represented here on the bottom left. So if I wanted to access something like the author's name, and I know that the author property on a book represents the entire author object, my syntax would look something like this, right? Book represents my book object. It has an author property which links to, which nests, a complete author object. Once I get that complete author object, that author object has a property called name, which I can use to access the author's name and get something like a string of George Orwell. The important thing to remember here, to understand here, is that name, that property is not being referenced on my book object. it's being referenced on my author object, which exists as a property of my book object. Book has a property called author, and that author property corresponds to a complete author object. As another example, if I wanted to call a method like complain on my author object, but I'm starting from a book's perspective, I begin with the book object, I reference the author property to get the author object, and on that author object, I have a method called complain, which I can invoke here. Let's once again tie this concept back to Excel. So let me provide you one example. In VBA, we have this concept of a range object, and a range just represents a clump of one or more cells on a worksheet. Like any object in VBA, a range object includes properties and methods. Some of the properties on a range object correspond to other objects. For example, range has a font property. That font property returns a brand new font object. That font object has its own set of properties and methods. This is the equivalent of our book author example. You can think of range as the book and font as the author. Font is a nested child. It's a nested object within range. That can be accessed again with .syntax, and that has its own set of properties and methods. Now this example is very simple. It's just a two-layered example, right? There's two tiers. There's this parent object and then there's this child object. Excel is a lot more complicated. So a single object can have a property that's going to be another object, and that nested object can have another property that's going to be another object. And that relationship can continue down many, many different levels, many different times, maybe 5 or 6 times. That hierarchy, that relationship, that collection of nested object properties that represent other objects, that whole shebang is what we call the Excel object model. It is the hierarchy of nested objects within VBA. The Excel object model is very complex. In fact, there are so many different objects in there that it's impossible to memorize. You can't possibly commit this to memory. But it's important to recognize that all of these objects are not independent, autonomous entities. Rather, they are related and connected. They're interwoven to each other by being nested within one another. And let me give you just a big picture overview that's going to go a few layers deep. At the very top of our VBA, we have an object called application, and this represents all of Excel, the entire open running Microsoft Office application called Excel. The application object has a property on it called workbooks. So it's going to be application.workbooks. That property of workbooks returns a workbooks collection object. Remember we talked about collections 1 or 2 lessons ago in the example of a bicycles? Workbooks is a property on an application object that returns a collection, which is a box or container, of multiple workbook objects. So we can reference from an application a collection. Then we can use that familiar parentheses syntax with the numeric index of a specific entity to get a single workbook object. A single workbook object is going to have a property called worksheets. The worksheets property is going to return another collection object, this time a worksheets collection object, which, as you probably can guess by now, is just a collection object that includes multiple singular worksheet objects. All right. Using, again, the familiar parentheses syntax, we can tell this collection of worksheets that we want to target just a specific singular worksheet. And on that worksheet object, we're going to be able to have a property called range, which is going to return another range object, which we can use to reference one or more cells. This is just one kind of blown up example. But you can see here this idea of the hierarchy. You can almost think of it like an ancestry diagram where you have parents and children. Application is the parent of this nested object called workbooks, and then workbooks is the parent of each one of these workbook objects. And this relationship continues further and further down. We're nesting it. We're kind of hiding these objects within other objects, and we're proceeding down this hierarchical chain until we get to the specific object that we want to work with, and then use its properties and methods to do something with it. So where we stop in the hierarchy in the Excel object model is going to depend on what we want to do. If we want to do something on a cell value, on a cell range, we're going to have to get down to the range object. That's where we're going to alter things like its value. If we want to do something on the workbook level, we're going to have to find a way to get to the workbook that we want to work with and call some of its methods like open, close, or save. All that programming in VBA is finding out where you want to be in this hierarchy, what object you want to work with, and then determining the right property to get, set, or the right method to invoke. That's all there is to cover in this lesson. There's just one other idea that I want to reemphasize if it isn't obvious. This Excel object model is exclusive to Excel, but each Office application has its own different object model with its own collection of objects. So Excel is going to have the concept of workbooks, worksheets, and let's say pivot tables, while a program like Outlook, which is used to send email, is probably going to have something like an email object or a contact object. So a macro that's going to work in one of these programs is not guaranteed to work in the other because the object model is different. If you want to add a pivot table, it's not going to work in Outlook because the Outlook object model, its own structured hierarchy of nested objects, has no idea about the concept of an object called a pivot table. Similarly, the reverse is true. If we wanted to send an email within Excel, we wouldn't be able to do this because Excel's object model, its hierarchy of nested object relationships, it has no clue of the concept of something like an email. These are totally different Office applications. They have total different object models, and all that an object model is just a hierarchy of nested object relationships. Among those relationships, we have the concept of collection objects, which are boxes for more than one object. We have singular objects like a workbook or a worksheet or an email, and all we have to do as programmers is figure out which one we want to touch, which one we want to access, and what we want to do with it. That's all there is to cover in the slides. In the next lesson, we're going to take this concept of the Excel object model and start exploring it in the context of our Visual Basic Editor. All right, so the time has come to explore the Excel object model within our actual Excel application. We're going to continue expanding on the concepts that we introduced over the last couple lessons. So here I have a brand new workbook open, and it has 3 total sheets right now: Sheet 1, Sheet 2, and Sheet 3. On my right side here, I have my Visual Basic Editor. As a reminder, if you want to open that up, there's a couple ways to do it. You can go to Developer and click Visual Basic. You can also use the keyboard shortcut Alt plus F11. For this lesson, I'm going to be writing all of my code within the immediate window, which is this pane at the very bottom of our VBE. You can, in fact, click and drag it to make its size a little bit bigger, and if for some reason the immediate window is not showing up for you, you can use the keyboard shortcut Control plus G to bring it up. The immediate window, I think we discussed it a little bit previously, is a console of sorts. It's a playground. It's an interface where you can perform basic VBA code calculations. So you can use this thing to test out little snippets of code. It's not designed for complex procedures, but whenever you want to, for example, check the value of a property on an object or see how a method would operate by itself, you can always run it in the immediate window just as a playground of sorts. Now, there's actually 2 syntactical options that are available to us when using the immediate window. The first of them involves using a question mark, and you can think of the question mark as asking a question. And whenever we ask a question, we are querying some kind of expression or querying some kind of object. So you can think of a question mark as, again, asking a question as compared to something like issuing a command. So whenever we are getting a property on an object, that is asking a question. We want to find out what the current value or the current state of something is. Whenever we are setting a value, or for example, invoking a method, those are commands. Those are instructions. So whenever we have instructions, we don't need the question mark. Whenever we are asking a question or ascertaining the value of something, that's when we do the question mark. So as one example here, I can write some very basic VBA code. I'm just going to do a basic mathematical expression. I can do 1 here, and then the plus symbol, and then 1, and this is going to perform the basic mathematical calculation of 1 plus 1. Add those 2 up to get 2. So again, we're asking a question, so we want to prefix everything with the question mark. So let's go ahead and explore a few properties that are available across several objects in the Excel object model. What I'll do here is use another question mark. I'm asking a question here. And we know at the top of our hierarchy we have the application object that represents the entire Excel app itself. Now, as soon as I put a dot here, we're going to see this feature called IntelliSense pop up, and IntelliSense is going to give us a list of all of the properties and methods that are available on the given object, which is the object that is right before the dot. So as we're putting in different values here, we're going to see totally different pop-up menus pop up. So what we have here is a list of all of the properties and methods that are on application, and as soon as I type any kind of letter, it's going to filter the results based on what we type. So I want to look for a property here called name. It begins with a capital N. So as soon as I type that, it's going to be filtered. It's going to go directly to that place in the list alphabetically. We have it right here, and then we can press the tab key to lock it into place. This is often recommended because it reduces the probability that you're going to make an error when you're typing out the name of a property. If a property doesn't exist, of course, VBA will give you an error. So we're asking a question here, application, that's the object. Tell me the value of your name property, and when I execute this with enter, of course, we're going to get Microsoft Excel. Now let's dive into a little bit more of a complex example. What I'm going to do here is just clean my work right here. And before I begin in the immediate window, I want to go right here in my workbook to sheet 1. And on sheet 1, cell A1, I'm going to write a value into that cell, and that's going to be hello world. And what I'm going to try to do is use my immediate window to reference this cell on this specific worksheet, in this specific workbook, in this specific application, and get its value printed to my immediate window. How can I do something like that? I'll begin with a question mark, again, because I'm asking a question. The question is, what is the current value in cell A1? Let's begin at the very top of our Excel object model and then proceed further downwards and navigating that hierarchy. So we know at the very top we have application. That is Excel itself. And then we know that we have certain properties on objects that nest other objects. So on application, we have a property called workbooks. Workbooks, as you can tell by the plural form, is a collection object that stores a bunch of workbook, singular objects. How can we access any one of those workbook objects? We use the familiar parentheses notation where we put a pair of parentheses and then the number of the workbook that we want to extract. In this case, we only have one workbook open, so there's only one option available to us. The first count, the first item starts at 1, so we're going to extract the workbook in that position. So we've moved from application to workbooks to a single workbook. So when I put the dot here, the properties and methods that we're going to see here are those that belong to a single workbook, not the workbook's collection object. You have to be very careful here. On a workbook object, we have a property called worksheets. Worksheets is going to give us another collection object of all the worksheets within this workbook. In this case, we have 3. And we can reference sheet 1, which is the first one in line, again, with this familiar syntax of parentheses and the number inside it. So the number here, again, is going to represent the number of the worksheet in line. So in this case, sheet 1 is sheet number 1 as well, and sheet 2 is sheet number 2, etc. But if your worksheets have names, for example, finances or revenues or expenses, this syntax is going to extract them numerically based on their position. All right, so now we have a single worksheet object, and on a worksheet object, we have a property called range. Sometimes the IntelliSense feature doesn't work as expected, but that's totally fine. We have a property called range, and with range, we can actually provide what's called an argument, and this is going to specify the specific range, which is just one or more cells that we want to target on this specific worksheet. Now, whenever we're using the syntax in these parentheses, we have to provide it what's called a string, which is just a clump of characters. The way we do that is with double quotes. So whenever you're creating a string, whenever you want something to represent text, for example, a name or a month, whenever you're going to type out something that's not numeric, you need to use a string, and that's wrapped in double quotes. And what we need to put here is the actual cell reference or range reference. In this case, we only want to target one cell, and that's going to be cell A1. Now, as a side note, this notation that we're using here is actually called A1 notation. It's a little bit confusing because right now we're actually literally referencing the cell A1, but that's where the term comes from. The idea behind A1 notation simply means that we use a letter for the column and a number for the row. So we're referring to our column by letter, whether it's A or C or D or E, it doesn't matter, and we're referring to our row by its number, like 1 or 5 or 10. So whenever that kind of methodology is used, we call that A1 notation. Okay, so now we have a valid range object, and as it turns out, a range is actually going to have a ton of properties and methods available to it. You may look at a cell like A1 and say, well, it's obvious it's hello world, but of course, a cell actually has a lot more properties and characteristics than simply the value it's holding. A cell, for example, has a font, it has a font size, it has a background color, it has a font color, it has a border. All of those properties, in this default example, they're not visible so much, but they all exist and they're all stored by VBA, and VBA keeps track of that stuff. So when we have the range, we actually want to specify the specific property that we want to access, and in this case, if we want the actual value that that cell is storing, there's a property on a range object called value. And this long syntax is going to actually give us hello world. So now we're successfully referencing that property. And again, we're using the question mark because we're asking a question. Well, what if we actually want to actually set this value? So instead of getting a property value, we're going to set a property value. That will allow us to actually overwrite what's currently in cell A1. How can we do that? Well, the first thing we need to realize is now when we are setting a property, just like when we're invoking a method, we are now giving a command. And whenever we're giving a command, we no longer need the question mark because we're not asking a question, we're giving an order. So we can limit our syntax a little bit here. And now, instead of referencing value, what we want to do is assign it. How can we do that? By now we should know it is the equal sign, and on the right side of the equal sign, we can put our new value. Now in this case, I'm going to use a string because I want to replace hello world with this text goodbye. So I'm going to begin my double quotes, type goodbye, close my double quotes, that's very important. And when I press enter here to execute, take a look at the left side, you can see that goodbye will now be the value in cell A1. So I can sort of guess what some of you are thinking. You might be looking at this syntax and saying, wow, that's a lot to write to reference a single cell, and you'd be correct. But luckily, VBA offers us a little bit of help. It gives us some shortcuts that we can use to cut down the total amount of text and object references that we have to write. When a range object is referenced like this, with every single part being explicitly mentioned, the application, the workbook, the worksheet, that's called a fully qualified reference. And that name makes sense because every detail of it is explained, it's qualified. However, we don't have to be this explicit because VBA can make some assumptions for us. For example, if we're dealing with something like a workbooks collection object, that only exists within the confines of an Excel application. So if we leave out, for example, application right here, and in fact what I'm going to do here is just go back to our original syntax of getting the value instead of setting it. So I'm going to remove goodbye at the end here, remove the equal sign, and also put the question mark back at the beginning. So all I've really done here is just remove application. VBA is smart enough to assume that, hey, if you're working with workbooks, you're probably working with Excel. You don't need to write that. I can figure out the application. So when we execute this, we're going to get a predictable result, goodbye. But notice that we don't have to be so explicit with all of our references. We can actually continue to whittle down this code even further. So right now we're explicitly mentioning a workbook, which can make sense in certain coding contexts. For example, we may have multiple workbooks open at a single time and we want to clarify which one we want to, for example, perform an operation in. But in this case, what we really want to do is basically reference the one that's currently active because that's the one that's currently open. We only have one workbook open here, and the active workbook is the one that is currently selected or activated by the user. We only have one. And so if we actually take out this syntax that we have right here of workbooks 1, I'm going to go back to the beginning of this line and remove this. What's actually going to happen is VBA is simply going to assume that you mean the active workbook. And again, the active workbook is just whichever one the user is literally clicked into. That's an assumption. That's not an assumption that you always want to make. For example, if you have this workbook open, but you want to copy a value and paste it into workbook number 2, you have to make sure that you explicitly clarify that that's workbook number 2 that you want to do some kind of operation is in, because VBA will assume that it's the active workbook. We'll assume that it's the active workbook whenever it's not explicitly clarified. In this case, since we only have one, we don't have to worry about it. So again, when I execute this, we're going to get the value goodbye. Let me provide you yet another example, but this time with worksheets. The exact same logic is going to apply when it comes to worksheets. We have this concept in VBA of the active sheet. And the active sheet is whichever one is currently selected. So right now on my Excel interface, we can see that sheet 1 is my active sheet. And right now it's sheet 2, and right now it's sheet 3. So what I can actually do here is once again remove my question mark, and let's write in a brand new value. Let's write in something like ha ha ha. And what's going to happen if I remove this worksheet reference is that VBA is going to assume that I mean the active worksheet, whichever one is currently activated. So right now when I execute this code, again removing the question mark because I'm issuing a command, our active sheet is sheet 1, so that's where the value is going to be overwritten. So when I execute this, we're going to get the value of ha ha ha. But notice what happens if I click into sheet 2, which currently has no content, and then I go back up to this line and execute. I'm also going to get ha 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 written in sheet 2. So the active sheet is being dynamically determined. Do you want that to happen? That is up to your project demands. That is up to your business needs. If you want the current operation to affect the active sheet, whichever the user is currently clicked onto, then you don't need to explicitly clarify the sheet that you're referencing. However, if you want to explicitly make sure that you're targeting sheet 1 or sheet 2 or sheet 3 or whatever, then in that case you do have to provide your object references. It all depends on what it is exactly that you're building and what your design vision is for it. That's really all there is to cover in this lesson. To sum up the big point here, it's the idea that references should be used up to the point that they clarify what VBA should work with. If something is obvious, if we're only working with one workbook, which is obviously going to be the active workbook, then you don't really need to clarify that that's the workbook that you want to reference. You certainly can. We took a look at fully qualified references a few minutes ago, but you don't have to. You can let VBA do that assumption for you. That's really all there is to cover here. We walked through some of the parts of the Excel object model, beginning with application, moving into the workbooks collection, then into the workbook object, then the worksheets collection, then the worksheet object, then the range object and its properties and values. So we actually navigated across something like 6 or 7 objects. It's a pretty complex operation. It may look simple, but there's actually a lot going on here. And of course, you don't have to keep this all committed to memory right now. As we proceed throughout the course, we're going to explore many different parts of the Excel object model, various properties and methods available across this entire hierarchy, across this entire tree of relationships between parents and children. But go ahead and explore some of the properties and methods that are available. Try using the immediate window with the question mark to see some of the properties and methods that you can activate with IntelliSense. Just poke around here, have fun, and I'll see you in the next lesson. All right, so we've talked a lot about collection objects and the individual objects that they contain. We know that we can extract an individual object from a collection object by using its index position, which is just a numeric count of that object within the collection. As it turns out, we can also refer to an object by its name. For example, right here in the immediate window, instead of writing workbooks 1 to reference the first workbook that's open, I can actually provide as a string the name of the workbook that I want to extract out of this workbooks collection. Right now, I only have one workbook open. That's the Excel object model workbook that we see right here on the left-hand side. But regardless, no matter how many we have open, we can always just extract them with the simple syntax of the name of the workbook as a string. We do have to remember to include the actual extension of the workbook in order to make this feasible. One thing I want to do here before I continue, though, is expand this window a little bit more so we can take a look at the actual code, because it's going to be a little bit of a big piece of code. All right, so here we have our workbook selected, and now we can go ahead and reference a worksheet within that workbook. And predictably, just like with workbooks, we can extract a worksheet collection object, or a single object that is, by giving the name of the worksheet instead of its numbered position as well. So for example, if I want to reference sheet 1, which is one of our available sheets, I can write it like so. Then I can provide my range syntax. Let's just do A1, and let's give it a value. Let's write the value of hello world here. Again, that's going to be a string, so I wrap it in double quotes. When I execute this, we can see right here on my left-hand side, hello world has appeared. So everything is functional. We've referred to a workbook by name and a worksheet by name, and that's just as valid as using a numbered syntax. What's really interesting about this is that the name is actually not case sensitive. So for example, my file name is all lowercase characters, but if I accidentally typed in capital letters like Excel, and maybe put a J capital here, and maybe put a sheet 1 here, but I capitalized the 2 E's, this would still work. So let me go ahead and delete hello world right here. Let me go back to my code right here, scroll all the way to the right and execute it. Here we go. You can see the result is the exact same. So just because the casing of the characters isn't the same, VBA is still able to figure it out. Now it does have to actually be a valid name. So if you mistype the name of the workbook or the worksheet, that will cause an error. For example, if I remove this L right here and try to execute it again, in that case, we're going to get this subscript out of range error, which simply means it can't locate the workbook or worksheet that we're looking for. But as long as the name is correct, the actual letters themselves and the casing doesn't matter. Finally, the last thing I want to bring up in this lesson is that string references can actually be paired with index position references. So far we've only used index positions or only used strings, but we can mix and match the two. For example, I can refer to this workbook by name, but this worksheet I can extract, let's say, the first worksheet with the numeric position. So I can mix and match a string right here with a number right here. We're going to get the exact same result. Let me just go ahead and delete that, execute this. There we go, same result. And I can also mix and match in the opposite direction, so I can change this workbooks to refer to the first workbook by using a number while still referencing a sheet like sheet 1. Let me just make sure I close that double quote. And when I execute this, exact same thing, hello world appears in cell A1. So we can access objects from collection by name or by index position. It really is up to user preference. Sometimes it's better to use one or the other, depending on which one is least likely to change. So if you know that people are going to be moving worksheets around a lot in terms of their order, it might be safer to refer to it by name. If you know that people are frequently going to be changing the names of the worksheets, it might be a better idea to refer to them by their actual position in line. In this lesson, I wanted to talk about default properties. So as we know, objects in Excel have properties, and those properties store that object's state. For example, in the last lesson, we talked about the range object, which represents one or more cells. And a range object includes a value property, it includes an address property, it includes a font property, and more. Now, even though a range is much more complex than just the value it's holding, we intuitively as users have this understanding that basically the most important thing about a range is the value it's holding. We can make a cell on the Excel interface a lot prettier. We can add some kind of fancy font. We can give it a border. We can give it a highlight. But at the core crux of it, Excel is a data analysis application. So we understand that the most important thing about a cell is really the value it's holding. VBA has that same kind of mentality in the sense that for certain objects, they will have something called a default property, which means whenever we reference that object, we don't have to include that property for specific objects because VBA will automatically assume that we're referring to the default property. Let me give you a couple examples and this will make things clearer. So here in the immediate window, I want to show you the code we relied on in the last lesson. If I want to find out the value in cell A1, I can just enter range A1 and value, and we're going to get hello world. As it turns out, value is the default property on the range object, which means it's automatically assumed by VBA. It's just so common, it's just so likely that that's the property that you want to reference on that object that VBA takes it for granted that if you're referring to a range, you probably want to find out its value property. So if I execute the exact same code, but I leave out the value property, Excel will access the default property on the range object, which is value, and it's going to give us the exact same result. Let me give you another example. We talked about the application object, which sits at the very top of the Excel object model. If I enter application here, we know that application has a name property, which we can manually enter here and execute. Well, as it turns out, name is the default property on the application object. That sort of makes sense because an application can do a lot of things in Excel. We can use application to perhaps save or do some kind of process, but the most important detail about an application, the most important property available on it is its name because that identifies it for what it is. So as it turns out, because name is the default property on an application object, we can just enter application and get the exact same result. The reason I wanted to introduce this concept of default properties is because you might find it in other people's VBA code. With that said, I personally don't like the concept of default properties. I don't like the syntax because it relies a lot more on implicit assumptions. A person has to be a bit more familiar with the concept of the Excel object model and the concept of default properties to know that when they type range A1, they're specifically going to be referring to the value property of range A1. So throughout this course, I'm not going to be relying on default properties at all. We're going to be explicitly writing out every single property that we reference. If we want to change the value in a range, we're going to be writing .value equals rather than just the range, all right? I think this will help us reinforce the concepts of the Excel object model, and I think over the long term, explicit is generally preferred over implicit. Whenever you write things out, it makes your code clearer and a lot more understandable to other users. With that said, I wanted to make sure you understood these concepts of default properties because you may find them in other people's code. In this lesson, I want to dive into the name property, which is actually available on both Worksheet and Workbook objects. There's two key takeaways in this lesson. The first is that properties can be both readable and writable. We saw an example of this earlier with the value property on a range object. And the second lesson to take away here is that permissions can actually vary from object to object. So a property on one object may only be readable, and on another one it may only be writable, and on another one it may be both, etc. So let's take a look at the name property on a singular workbook object first. In my immediate window here, I can go ahead and refer to my workbook by referencing the workbooks collection object and just getting the index position of 1. That's the very first workbook I have open. That gives me a workbook object, which has a name property. I can execute that. And we can see the name of this document, this file, is the name property.xlsm. I can also reference this workbook, by the way, by actually giving the string argument to the workbooks collection object. So I can actually reference the name property.xlsm. So referencing the workbook not by its numeric position, not by its order, but by its actual name. And predictably, that's the exact same workbook. So I'm going to get the exact same output. I can perform the exact same logic if I want to reference the name property on a worksheet object. So it's going to be the same property name, but it's a totally different object. So I have 3 worksheets in this currently open workbook, sheet 1, sheet 2, sheet 3. If I want to reference, let's say, the second one, I can do the worksheets object, give it an index position in parentheses. That's going to give me a singular worksheet object that has a name property. It's going to be sheet 2. I can similarly reference a sheet by using its name instead of its position. So I can reference something like sheet 3. Close my double quotes there. That's going to give me a worksheet object that has a name property, and that name, of course, is sheet 3. Hopefully all of this makes sense, but here's where it actually gets interesting. As it turns out, the name property on a workbook object and a worksheet object operates a little bit differently. On a worksheet, the name property can actually be overwritten with a brand new value. So we can use VBA to change a worksheet name. For example, let's say I want to change the name of sheet 1 to January. I can reference sheet 1. I can do worksheets, reference number 1, reference name, the name property, and this time I'm going to give it an equal sign because I don't want to get the value, I want to set the value, and I'll set it to a string of January. This time around, when I'm using the immediate window, I do not need a question mark because I'm not asking a question, I'm actually executing a command. So we can keep our eyes right here on the bottom left, keep an eye on this on sheet 1. When I execute this, it's going to change to January exactly, and we can also just verify this by going to our immediate window and outputting the value of that name property again. So right now it's January. So that's worked exactly as expected. The name property on a worksheet object is both readable and writable. However, on a workbook object, it is only readable. So if I try to change the name of this workbook, if I, let's say, want to change the name of this workbook to monthly results, I'm going to extract it with my index position of 1, get the name property, try to use the familiar equal sign syntax, but unfortunately, we're going to be met with an error here, a compile error. It reads exactly as we expected. We cannot assign to a read-only property. That's all there is to cover in this lesson. I just wanted to point out that certain properties can be shared among different objects, but the difference is that on some objects they may be readable, on other objects writable, on other objects a combination of both. So just because 2 objects will have the same property does not mean it's going to be exactly the same. You always have to do your research by diving into the documentation to seeing exactly how these properties work and what the functionalities are that are available to us when we're working with a specific object. That's all there is to cover here, and I'll see you in the next lesson.